Hey dudes, it's Tyra, back at it again with some super cool science stuff for you. So for those of you who are new to this channel, which is everyone because this is my first video, I'm a 14-year-old AI and machine learning enthusiast from Toronto. So for today's video, as you can probably tell by the title, I'm going to focus on a specific and really cool class of machine learning known as the Generative Adversarial Networks, or GANs for short. I'll get into specifics of that a bit later. Let me give you a bit of background first. So the term GANs was first introduced to the public in a paper presented by a U of Montreal professor, Ian Goodfellow, and quickly rose to fame in the AI community. So GANs can be used for a variety of different things because they have the ability to imitate any distribution of data. This means they can create their own original music or pictures or data and have the capability of making some pretty dope art too. So GANs are a deep neural net structure that are made of two different types of neural nets, making it competitive or adversarial against itself by nature. So in short, for those of you who don't know what a neural network is, they're like a technological imitation of the neural paths in your brain, and they're connected in adjacent layers to one another with more layers, right? So with more layers, you have a deeper neural network. Neural networks are a set of algorithms made to detect patterns, and they interpret data through a machine perception, enabling them to label or cluster raw data input. So let's start off by explaining generative versus discriminative algorithms because they hold a great part in the idea of GANs. So the goal of discriminative algorithms is to try and classify different types of input data. Basically, just being given examples and samples of data, they are meant to predict a label for it or map features to label. Some pretty simple supervised machine learning there, right? And then generative algorithms are quite the opposite. As opposed to giving a prediction of a label based on features, they predict features based on labels. So jumping back to GANs themselves, recall how I mentioned the two different adversarial neural networks. So these two networks are actually named the generator and the discriminator, pretty similar to what I described above, right? So the generator generates new data instances, while the discriminator tries to tell whether it's legit or created by a machine, specifically the generator. So the discriminator is actually fed a bunch of real-life images. Then it's given a sample of a fake and a real image, so one taken in real life and the other generated, and it identifies which one is real or fake. It shares the metrics that it's using to identify the difference between these two with the generator so that it can improve, right? It's like a self-improvement system. The generator part of a GAN learns to create fake data by incorporating feedback from the discriminator, and it learns to make the discriminator classify its output as real. This means that both of the neural networks improve over time. One of them is learning to generate better images, and the other is learning to differentiate between training data and fake data. So the generator does actually reach a point where it can be identified as making perfect fakes. So when the discriminator has like a 50-50 chance of guessing whether this image is authentic or not, the generator has pretty much beat the system. And that's kind of crazy. Yeah, it's an internal improvement system. And I guess you could call it that. It's kind of like playing a game of detective, with the discriminator being the detective and the generator being the culprit. The detective needs to find out who the culprit is by looking for clues to indicate who the person is, and the culprit needs to figure out what clues the detective has and disassociate with them completely. And okay, that's not really a game, that's just the show Sherlock, but it's just such a good show. I relate everything back to it. And that might be the reason why I decided to make a personal project on GANs. So I'm actually going to be making a GAN that allows me to make artificial dog pictures. How neat is that? Pretty neat, right? So I'm going to be using this by firstly using a special type of GAN called the DCGAN, with the DC standing for deep convolutional. Don't get scared, very simple. Basically, this is just a more sophisticated way of increasing the accuracy of the random idea generator, so the random noise, to a sample data using convolutional layers in the generator network, because this just produces better results. So I'll be creating this using PyTorch, as I'm currently doing a course learning how to use it on Udacity, and I'll put the link down below. And I'm going to be training these networks using a good 10K cat pictures to do so, obviously getting these images from another source. I do not have the time to find that many cat pictures. Gosh. So I think that about does it. Stay tuned for part 2 of this video to see more of my completed project, by the way. So yeah, that wraps things up. Thank you so much for watching, and have a great week. Bye!